Okay, in this video, we're going to dive into positive reinforcement more in depth. Now, remember the definition for positive reinforcement, right? So this is behavior produces, right? That's the positive part of it. Behavior produces something in the environment. In this case, it's an appetitive stimulus, or like Thorndike said, positive consequences, right? And so if it's an appetitive stimulus or positive consequences, that's going to reinforce future behavior, make it more like that same behavior, more likely that same behavior will happen in the future, right? It's a positive reinforcement. So let's first talk about a few parameters. This is, I think a lot of it's fairly straightforward, but the amount of, in here we're talking about the amount or the quantity of the reward itself. So like the food that you're giving or whatever it might be. And the relationship here is the larger the rewards, the faster the acquisition. So quicker the animal, the person will learn the association between behavior and the reward, and you get a greater level of responding or rate of responding if we're talking about observations in an operant box. Could be faster running speeds if we're talking about maze running in a discrete apparatus. So that we could manipulate the reward by giving 2 pellets versus 10 pellets, that sort of thing, right? The quantity of the reward. Hopefully that makes intuitive sense to you. Now the magnitude of the reward refers to the quality. So now we're not talking about the volume of it, but the quality of that reward. This is best illustrated in an experiment by Collier. And what Collier did is he had rats bar pressing for access to a drinking tube, and the reward size was kept the same. It was 1 milliliters of a water-like solution. And the water was, the concentration of saccharin was varied. So saccharin is a sweetener. So one of the solutions was a 4% saccharin solution. The other one was a 64% saccharin solution. So one was sweeter. The 64% was much sweeter than the 4%. Now remember, the size is always the same. And Collier looked at the response rate for these different reinforcers, and the response rate was much higher for the 64% saccharin solution than the 4% saccharin solution. So this tells us that the quality of the reward can also influence behavior, a lot like the quantity of the reward. The best example I can give you is, we're in New Jersey, and so pizza is not all of the same quality. So it's like you're working for, reinforced by just the promise of pizza, like Domino's Pizza, versus like a local pizzeria. The quality influences your behavior, right? Reinforcement delay. So the time between the behavior and the reinforcer. As you might imagine, the shorter the time between the behavior and the delivery of the reinforcer, the faster the learning takes place, right? The sooner the animal or the person can learn that there's a relationship between the behavior and the consequence, in this case, the delivery of the reinforcer. If you have lots of time in between those things, that's harder to make that association. So if you're training your dog, you should reinforce them right away, immediately. So like when Tank finishes an obstacle in our or a sequence of obstacles in our agility training, I praise him right away as soon as he's done, because you don't want a lot of time. You want him to know that, yes, I did the right thing right away, immediately. A couple of other concepts here, and this elastic and inelastic reinforcement comes from essentially mapping behavioral learning concepts onto economic concepts. And there is a whole behavioral economics field out there looking at how people's buying behavior is influenced by these learning principles. And so this idea of elastic reinforcement is consumption, and here consumption in an operant situation is the number of rewards that are obtained. So if you get 1 reward, you've consumed, 1 thing. If you get 10 rewards, you've consumed more. That's the idea. So the consumption is highly dependent on the cost. And the cost in an operant conditioning situation is the number of behaviors that are required to obtain a reward. So let's think the prototypical example of a rat in an operant box pressing a lever to get a food reinforcer. So the cost here is how many times does it have to press that bar in order to get a food reinforcer, right? So here with elastic reinforcement, the consumption is dependent on the cost. So if the cost gets too high, the animals stop consuming, they stop working, right? So you see this in an open economy. Remember the example before that we were talking about with an open economy where the animals can go to their home cage and get free food and water. So if the cost gets too high, if you're asking the rat to press the bar 100 times to get a food pellet, it might just give up and be like, I can get food later when I am in my home cage, and that's too high a cost for me to engage in this behavior. That's something that's also referred to as ratio strain, right? So the ratio gets too high, the animal just checks out and does not continue to respond. So think of this as like a luxury. So it's a luxury. Hey, I don't need to work this hard for this, so I'll stop working. So that's elastic reinforcement. Now, inelastic, on the other hand, the consumption here is the same regardless of the cost, right? So you can increase the cost. The animal has to continue to respond because it needs to. It's a necessity, right? So you'll see this in closed economies. If you're working for food or water and it's a closed economy, well, you're going to starve or you're going to be deprived of water if you don't work. So you have what's called inelastic reinforcement. You see inelastic reinforcement sometimes with drug addicts will often show inelastic reinforcement. That is, they will do whatever they need to do to get access to that drug. So some of them can show at least some evidence of inelastic reinforcement. For a long period of time, the oil companies used to think that our gasoline consumption in the United States was inelastic. That means that whatever the cost was, they could keep raising the cost and we would still consume roughly the same. They hit a mark when it hit about $4 many years ago, maybe now 10, 15 years ago. Our consumption went way down and they realized that maybe it wasn't as inelastic as they originally thought. Maybe it was a little bit more elastic than they thought. So elastic, inelastic reinforcement are economic principles applied to positive reinforcement. So there are some schedules of reinforcement that we're going to go over. So you can deliver a reinforcer at different rates. And one of the things that you could do is you could fix the ratio. So this is when the reinforcement depends on a fixed number of behaviors. So if we're talking rat pressing the bar in the operant box, an FR1 would mean fixed ratio 1. Every time they press the lever, they get a food reinforcer. So this is what you would do when you're training them. You put them on an FR1 schedule. An FR10 schedule, on the other hand, they would have to press the bar 10 times to get a food pellet. Then they'd have to press the bar 10 times again to get the next food pellet. And by the way, a trial begins as soon as the animal's put in the operant box and the machine is turned on. And a trial ends when they get a reinforcer. So that's what we mean trial to trial. So as soon as you get a reinforcer, that would start the second trial. So the animal could take its sweet time pressing 10 times. As soon as it presses the 10th time, it'll get a reinforcer. That begins the second trial. They would have to press the bar 10 more times in order to get the next food reinforcer. And this is our cumulative recorder showing you the pin. And you can see that each time the animal presses, the pin goes up a little bit and it creates these little zigzag pin marks. And then when it gets a reinforcer, it'll give a little back tick here on the cumulative recorder. So if you put an animal in on a fixed ratio schedule and give them a lot of experience with this schedule, their behavior will stabilize. And when it stabilizes, if you look at the cumulative recorder, it looks kind of like this. It looks kind of like a little staircase where they'll work pretty steadily. They get the reinforcer. That's what this little back tick means. They get the reinforcer. They wait a little while, and then they'll start working again, and then they get their next reinforcer, and so on. So you end up with this sort of staircase-like function on a fixed ratio schedule. Now this period of time here is called the post-reinforcement pause. So they will pause a little bit in between, right after they get the reinforcer, rather, before the next schedule. So there's two factors here that determine the length of a post-reinforcement pause. One is the size of the reinforcement. Larger reinforcers result in a longer pause. It takes a little bit longer to eat. The ratio size, the more the animal has to work for its reward, the longer the pause as well. So you'll get a longer pause for an FR25 than you would an FR10, for example, because they have to work a little bit harder. They wait a little bit harder, a little bit longer to get going. So that's fixed ratio. We can also vary the interval. And in this case, in an interval schedule, it's the first response after some fixed time period is reinforced with a delivery of a reinforcer. So you could have a FI 10 second. So that means the first response after 10 seconds is going to be reinforced, or an FI 30 second, first response after 30 seconds would be reinforced. There's no penalty for pressing the bar or pecking the key early. And if you have an animal on these fixed interval schedules with a lot of experience and their behavior becomes stabilized, if you look at their cumulative recorder, what will happen is near the end of the interval, so let's say it's a 30-second interval, near the end of the interval, so like right around 27 seconds, they start to get really active and peck or press a lot, and then they'll get their reinforcer. And then there's not much activity, and then they peck or press a lot towards the end of the interval and get another reinforcer, and so on, such that you end up with this sort of sloping like cumulative recorder that has sort of a scallop to it because they're really active towards the end of the interval. So it's not perfectly optimal, right? Perfectly optimal behavior would be wait exactly 30 seconds and press the bar one time. They wait close to that interval. So yeah, they can tell time. This is evidence that they can tell time. It's not exact, but it's an approximate measure of time. And then they respond a lot when the time interval is nearly up. Now, we can also take these ratio or interval schedules and we can make them variable. So the other examples, they were fixed. That means every trial was the same. So if it's a fixed interval 10 second, every trial, once you get your first reinforcer, the next trial also have to wait 10 seconds. But we can vary that if we want. So variable ratio means, or reinforcer is delivered around an average number. So I've given you an example here. Let's say it's a VR10 schedule. That means on average, the 10th bar press will be reinforced. So the first trial, it might be 2 presses and you get reinforced. And maybe the 7th response, it's 5. And maybe the 13th trial, you have to press the bar 12 times and so on, such that when you look across an entire session of like an hour-long session, the average is 10. Same with the variable interval. First response after the time interval is reinforced, but that time interval varies. Could be 2 seconds, 5 seconds, 12 seconds, etc. But all around some average, in this case, a 10-second interval. So now what happens with the responding on these schedules is the animals don't really know when the reinforcer is coming. So it could be the next bar press, right? It could be the next one that pays out. So what you get is you get a very steady responding rate with intermittent reinforcers that are delivered, right? This long line would indicate that the pin is reset here, and then they start responding again. So you get this nice steady responding with variable ratio, variable interval. It's really hard based on the cumulative recorder to tell the difference between a variable ratio, variable interval. They look very much the same and can often be the same depending on the parameters of it. But you get this nice heavy responding on these schedules. Okay, a couple other schedules. You can have a fixed or variable time. So in this case, there's no response required, and the reinforcer is just delivered after a certain time interval. So remember the magazine training that we talked about for pressing the bar? You just put the animals in the operant box, and every 30 seconds or so, it delivers a food pellet. Well, this would be a fixed time schedule. Now, you could also have a limited hold. So a limited hold could be applied to any reinforcement schedule, and this is when the reinforcer is only available for a specific amount of time, and you have to respond before the time expires in order to obtain the reward. So let's consider like a fixed interval 30 second with a 2-second limited hold. That means first response after 30 seconds, but before this 2-second limited hold elapses would give you a reinforcer. Now without the limited hold, they could wait however long. They could wait 60 seconds, press the bar, they'll get reinforced. But in this case, if they wait 33 seconds, press the bar, they won't be reinforced, right? So it encourages responding within a certain time limit. And if you think about limited hold, lots of examples are out there, right, of businesses that use limited holds, right? Like limited sales are available, right? Or good values, but only on this particular day, right? Limited hold. So response rate schedules are when you reinforce a rate of responding, not an actual number of responding. And you can do this two different ways. So differential reinforcement of high rates, you would set a contingency like 12 bar presses in 30 seconds. And so then you're responding, or you're reinforcing rather, a rate of responding. This is kind of like a points card. So if you go to a sandwich shop and they say you have to get 6 sandwiches within a week, or that's a lot, 6 sandwiches within a month, then you get a free sandwich. They're trying to use this DRH schedule on you to increase your buying behavior. Differential reinforcement of low rates is the opposite. So in this case, you have to withhold your responding. So you can't respond for 30 seconds. If you do respond, say you respond 29 seconds, the timing, there's a penalty. The timing would start all over again. You'd have to wait another 30 seconds before you could respond. So you'd have to respond at 30.1 seconds before you can get your reinforcer for the differential reinforcement of low rates, or DRL schedule. Now, one thing I want to just briefly talk about is remember our concepts of generalization and discrimination that we talked about with classical conditioning. They exist in operant conditioning as well. So generalization is when you have the same behavior that generalizes or is triggered by a similar stimulus, right? So remember the Skinner video at the very beginning with the pigeon either turning or pecking. In that case, the two different stimuli elicited two different behaviors. And we would say that the animal discriminated between those two stimuli. If the animal, and early in training, certainly they did, pecked both of those images, for example, then it would be generalized. In other words, to the bird, the words look the same, it pecks them both and generalizes the behavior until it gets a lot of information to indicate, hey, I have to learn a different behavior for this, right? So generalization and discrimination works just like it did with classical conditioning, but we have different kinds of contingencies here, right? So similar to classical conditioning, failure to discriminate could be from an inability to tell the stimuli apart, right? So like if the stimuli weren't salient enough, or let's say that pigeons are colorblind or something like that, and the keys look the same, you might get a failure to discriminate. Another possibility is you lack stimulus control. What I mean by this is if the keys are too close together, the pigeon might peck them anyway. So you'd have to be careful and make sure that the keys are far enough apart that they're not just going to peck them because they're close together. We also would have to control for left-right position because they might learn to respond to a side instead of a color, right? So what we think is salient is not necessarily what is salient or what the animal is learning. We have to be mindful of that and create tasks or create conditions that allow the animal to discriminate based on the stimuli that we want to discriminate. So discrimination is important. It's important for animal training. If you think about it, you're going to give different commands, and you want those commands to be as clear as possible or as different as possible. If you're trying to train your animal on similar sounding words, it might be very difficult, and they might not ever discriminate between those two stimuli because they sound the same. So pick really different words, really different commands, and you'll get a lot better results. So that's generalization and discrimination in operant conditioning. So we'll talk a little bit about multiple schedules. So multiple schedules, so far we've just talked about schedules operating one at a time, but you can do this however you want. You can have more than one schedule in operation at the same time. And with a multiple schedule, you can actually observe some interesting phenomena. So one phenomena that can happen is something called positive behavioral contrast. This is when Performance goes up on an unchanged schedule when the other schedule gets worse. So let me explain, and then you can sort of see the phenomena here. So let's suppose that we have a red house light, and when the animal's been trained to press a bar for food, and it's a variable interval 10-second schedule. So you're going to get a nice steady response rate. Now I'm plotting response rate here, not the cumulative recorder, so it's a nice strong response rate over the entire session. Let's also say that we train the animal, use a greenhouse light, and it's a variable ratio 10. Also a nice steady response rate on these two schedules, right? So that's the idea for the first part. You could have one schedule signaled by one color, different color signals a different schedule. Now, what happens when we change it? Well, let's say that we take the red and put them on extinction. So now we're making this schedule worse, right? Extinction means you don't get any reinforcer at all. And what happens is what you would expect to happen. The response rate drops off, right? There's no point in responding because you're not getting a food reinforcer. So performance gets worse here because the schedule got worse. That makes sense. The point is what happens on this unchanged schedule, right? If there's no carryover here or no impact from this change, we should see just a flat line that continues across, and it should continue to respond on the green schedule as it had done before. But instead what happens is performance goes up. This is what's called positive behavioral contrast, right? Performance goes up on the unchanged schedule, right? So it's like you're working two jobs and you work along steadily. And then one of your jobs, they come in and they say, hey, we're going to have to cut your hours back because, whatever, cut your hours back. And then all of a sudden you work a lot less hard on that particular job. And instead, your other job that you go to, you're just thankful that you have that job. You might work a little bit harder, right? This idea of positive behavioral contrast. We can also have something called negative behavioral contrast. Same situation here, but now we make our schedule better. So like with the red schedule, we're not going to make it worse, we're going to make it better. So FR1 gets paid out much better than a variable interval 10-second. And as you might imagine, performance is going to go up on that schedule. The point here is that this unchanged schedule, performance goes down, right? Performance goes down on the unchanged schedule when the other schedule gets better. So the negative behavioral contrast. So imagine you're working two jobs and you come in one day, and at this job they say, hey, you've been doing a great job, we're going to give you a raise. And then you're like, yay, I get a raise, and you start working harder, your motivation's higher. But what about that other job that didn't give you the raise? You start to have less motivation, less energy for that particular job, probably due to this negative behavioral contrast. We can also have schedules operating at the same time. This is what's called a concurrent schedule. So you could have two schedules operating at the same time. The animal can, you could have two keys, you could have two bars, and the animal can press whichever one they want and allocate their time however they want. We won't go too much into it, but you can look at choice behavior with these concurrent schedules, and it's really just limited to your own creativity and whatever you set up. Now, a chain schedule is when you train the animal on several smaller little schedules. So let's say, for example, I train the animal on a fixed interval 60-second schedule, and I'm going to signal that with something like, say, like a light. And then I have an FR10 schedule, different light, and a VR20 schedule, different light. And you train them up on each individual piece of the chain till they know what they're supposed to do when they're given that individual signal. Now in a chain, what you do is you link these schedules together. So for the FI 60-second, for example, that might be the first one in the chain. They first bar press after 60 seconds, changes the color of the light to the FR10 schedule. Now they have to press the bar 10 times. Now it's a variable ratio of 20, so they press on average 20. Now they get reinforcement at the end of the third schedule, at the end of the chain, right? So you link all of your schedules together in order. You have to complete each one to move to the next, and then reinforcement is given at the end. So this is how we do complex animal tricks, right? So I'll give you the example of the dog agility video so you can watch that on your own. But how to get these dogs to run these complex obstacle courses? Well, you train them on each individual obstacle a lot till that they get it, till they know what to do. Here's a picture of a dog on a teeter. They know what to do on the teeter. They know what to do with the tunnel. They know what to do with the A-frame, etc. You train them up on all of those, and then while they're running the course of an obstacle, they'll do several obstacles, and you give them reinforcement at the end. So that's what we're doing right now. We're in the process of sort of chaining more of these, and you do different combinations each time, so that they don't necessarily learn like only one set of one order of obstacles. But what you want to do is you want to give your animal a reinforcer at the end of each one. And if you notice trainers or animal, even like shows, like say like at SeaWorld and stuff like that, if you watch the trainers, they reinforce them at various points in time, usually when they've completed some sort of chain or sequence of scheduling. So watch that dog agility video and you can sort of get a sense of how complex the behaviors are. But you start with those individual pieces and train them for quite a while on each individual obstacle. All right, one last little bit here for this section. So we can have what's called an occasion setter. So an occasion setter is a stimulus that signals that reinforcement is possible. And I've circled here our house light. Remember the house light that I said? That would be illuminated, and it would let the animal know, hey, your machine is working and I can press the bar for food. And so when the session's over, you turn off the house light, and then the animal knows that it can no longer be reinforced for pressing the bar, right? It sets the occasion for reinforcement. There are human examples of this. So like when you walk up to a vending machine, if it's not lit up, if it's not lighted, you're probably not going to put your money into it because you don't think it's working properly. So the lights on the machines are going to set the occasion for reinforcement. But even people can be signals for reinforcement. I have a good example of this. Long ago, one of my friends was a stay-at-home dad, and his wife is a doctor, and she would be gone all day. And he was telling me a story. He was saying that his son was perfectly fine with him all day, but then as soon as his mother came home, he would see her and he would start crying and carrying on. And he didn't really understand why, but quite readily I realized that his mom was an occasion setter for reinforcing crying behavior, right? She felt guilty. If he started crying, she would give him attention, and he would get reinforced. So it was this sort of vicious circle that undesirable behavior was reinforced just by the presence of the mother. So parents can be occasion setters for different reinforcements. I'm sure many of you have examples of, like, you know when to go to mom, you know when to go to dad, and that kind of thing. So people can be occasion setters as well.